Welcome to the weekly Wuhan flu lockdown version of the Preferred Utilities webinar. For all of you quarantining at home, self-isolating, or even on vacation and can't get enough of the Preferred weekly webinars, we're going to discuss fueling systems for mission-critical emergency generators. Michael, our webinar coordinator, was careful to kick all of our competitors off the viewer list, so today we're going to go above and beyond and share some of Preferred's secret sauce with you. At the end of the presentation, we'll be joined by John Cadrich, a preferred fuel handling technician who starts up many of our big data center projects. If you have any questions, you can put them in the chat box or you can email them to me at deoff@preferred-mfg.com. We're going to take your questions at the end of this presentation. My email address is on every slide, so you don't even need to write it down. The first thing we're going to do is define a successful fuel handling system. First, it needs to reliably supply fuel to all connected generators. Second, it needs to prevent overfilling a tank and causing a spill. Third, it needs to detect leaks and take appropriate action. Fourth, it needs to communicate important information, like leaks, to the facility. And last, it needs to comply with all national, state, and local codes and practices. We have to adhere to NFPA 30, NFPA 31, NFPA 37, NFPA 110, as well as state and local codes. And for fueling systems, the authority having jurisdiction is the local fire marshal. I want to start off with a simple example to try and illustrate how preferred systems are designed with mission-critical facilities in mind. Shown here is a typical alarm circuit. This one is designed to energize a horn and alert a PLC if the oil level gets too high in a tank. Very simple. You've all probably seen alarm circuits like this one all over your plants, and they're all wrong. What could go wrong with an energized to alarm circuit like this? Because it's energized to alarm, anything that interrupts power will cause the circuit to fail to alarm. This could include a blown fuse, a stuck float, a loose wire in a terminal block, a broken wire, a dead horn, a dead digital input, or a malicious rodent. If this circuit fails, the alarm just doesn't go off. You usually find out after you've had a problem. Preferred would wire this circuit in an energized is okay configuration. We would wire the high oil level switch normally closed so that voltage in this circuit indicates the tank is not in a high oil condition. This way, if we get a blown fuse, broken wire, stuck switch, or malicious squirrel, the circuit goes dead and alarms go off before we also have a high oil level problem, so that the plant staff can troubleshoot the problem at their leisure. This is the way boiler controls have been done for decades. All the limits have to be proven all the time or the boiler trips off. This is a snip from an actual preferred wiring diagram. You can see we have a limit string like the limit string in a boiler flame safeguard system. All the normally closed pump permissives have to be made to energize the pump set permissive relay. All the normally closed day tank permissives and the normally closed high oil level float switch have to be made to energize the day tank permissives relay. Snipping from another section of the wiring schematic, we see the pump set permissives relay and a day tank permissive relay need to be made to energize the supply pumps. This is true whether the pump is in hand or in auto, which means the plant personnel can't put a supply pump in hand and overfill the day tank. In the Navy, this is called sailor proofing. In a multiple day tank project, we might trip the fill valve if the day tank level hits 90%, but leave the pumps running to supply other day tanks. That's just one example of how Preferred designs systems differently for mission-critical applications. Moving on to how Preferred likes to pipe generator fueling systems, it's important there is no single point of failure. We pump oil out of one of the main tanks through a positive displacement pump. We prove oil flow with a flow switch, and the oil goes to the day tank. If the oil level gets too high, the return pump is energized to pump fuel back to the main tank and prevent an overfill. We like to return oil to the same bulk storage tank we are pulling the oil from. If we allow the plant to pull from one tank and return to another, it introduces the possibility of overfilling the tank we are returning to. Important features of this fuel system include two main tanks, so there is no single point of failure at the main tank. There's very little that can go wrong with a main tank, but sometimes they are unavailable due to inspection or periodic maintenance. We have two pumps, each size to carry the load for the entire system. We have a flow switch that proves oil is flowing when we energize a supply pump. It's wired normally closed too. And finally, the return pump that allows the startup technician and the plant to exercise the fuel system periodically to prove it is working correctly. Without the return pump, the only way to draw down the day tank and test the system is to burn the fuel in the generator. Typically, generator tests aren't long enough to exercise the fuel system. The previous schematic was already pretty busy, so I left off the flow control manifolds. But in a system with multiple day tanks, a flow control manifold will be required at each day tank. That way, when we energize a supply pump to top off day tank 1, we don't put fuel into day tank 2 or 3. Very simple. Preferred flow control manifolds can have 1 or 2 solenoid valves, but they will always have a 3-valve manual bypass around the automated valves. The bypass would be used if a day tank is calling for fuel and a solenoid valve doesn't open. Or maybe there is a malfunction in the pump controls and the plant needs to override the pump controls and open the bypass valve and put a supply pump at hand to fill a generator tank in an emergency. Solenoid valves are not the most reliable valves to use in this application. Solenoid coils burn out, the valves get stuck closed, and debris can get caught in the valve, preventing it from closing all the way. So in some of our mission-critical fuel systems, we supply motorized ball valves instead of solenoid valves. The actuators are more reliable, and debris in the fuel won't cause them to leak by. Also, the actuators can have proof of open and proof of closure switches to prove to the pump controls that the valve is in the right position. We can also add a flow switch or flow transmitter to the flow control manifold to prove oil is flowing to the day tank when we start a fill operation. Or we can put a visual sight flow indicator in the line so the operator can see locally when oil is flowing into the day tank. Most day tanks don't have analog level sensors in them, so a flow switch can be very handy to make sure when the pump controls are trying to top off a tank that oil is actually getting to the tank. The most common thing to go wrong in this situation is someone closes one of the hand valves and doesn't open it again. This schematic shows the 4 switches preferred puts in the day tank to control the supply pumps, return pump, and fill valve. When the oil level gets down to 50%, a supply pump comes on, the fill valve is energized, and oil flow is proven with the flow switch. If the flow switch doesn't prove oil is flowing, the alarm goes off and the lag pump is energized. If flow still isn't proven, both pumps are de-energized and the alarm stays energized. If the oil level gets up to 90%, the fill valve and/or supply pump is hardwired de-energized and the return pump is energized. This slide used to show this function as well, but our intern that knows how to do PowerPoint animations got married and moved to Saskatchewan. True story. Preferred developed its own control hardware for our mission-critical fuel handling systems. The key to this controller is that up to 10 of them can be networked together on a redundant communication bus we call NodeNet. With distributed control, there is no central PLC that can fail and take down the entire fueling system. We call the redundant communication system the NodeNet. Devices connected via NodeNet can be as many as 800 feet away, and information for the entire system can be read at any of the local nodes. In this example, if you let the smoke out of one of the day tank controllers, all of the other controllers keep going. Distributed control means a lot less hard wiring in the field. It also breaks a very large problem down into a series of much smaller problems to make it easier for the technician to get their head around the system. Instead of one giant wiring schematic like you would have for a central PLC, you get one small wiring schematic for each node. This modularity also cuts down on the amount of custom programming required in a big system. The redundant communication feature of this controller is innate to the controller. You just connect 3 wires, usually a 3-conductant Belden type cable, and all connected controllers start to communicate. There are no Modbus settings, baud rate, parity, or any of that have to be matched up like a typical Modbus or Ethernet communication network. If a controller is completely dead, it can be replaced with a spare in minutes. All the wires are connected through plug-in terminal blocks, so physically taking out the dead controller and installing the new controller takes just a few minutes. For me, the longest part of the process would be finding the right nut driver in my tool bag. The program is reloaded with an SD card that fits in a little slot on the bottom of the controller. One SD card includes the program for all connected controllers, or all nodes. You just set a potentiometer to the correct node number for that controller, and when you power up the new controller, it reads its program off the SD card, boots up, and immediately begins running the new program downloaded off the card. I tell people to tape the SD card to the inside door of the enclosure so it won't get lost in an emergency. Most control hardware requires the program to be reloaded via computer, so the plant needs to have the right laptop running the right software with the right cable. It's a lot to ask in an emergency. Bear this in mind anytime you specify PLC controls. Preferred's engineers built this capability into the controller, but it has rarely been used. Our warranty rate on these controllers is less than 1%, and most of those failures occurred during initial startup. This is a short list of recent data system customers I could remember off the top of my head. These are recent systems Preferred has done with at least 8 generators, so big fueling systems are not unusual for Preferred. Now that we've shared a little bit of the secret sauce that goes into a Preferred mission-critical fuel handling system, I want to share a couple of case studies with you. I always find the best way to learn is from other people's mistakes. A cable provider in Texas lost grid power and had to run on its generators. After about 60 minutes, one of its generators shut down because its day tank ran out of fuel. Plant personnel were unable to figure out the problem before grid power was established. This facility had its own servers, and it had a contract with an outside company to host their servers. There were liquidated damages in the contract with this company of $1 million per hour if the servers went down, so this resulted in a $2 million outage. When they brought in a technician to determine what happened to the fuel system, they found there was a little silver metal toggle switch on the generator day tank that locked out the day tank supply pump. There was no label on the switch, and none of the plant people on duty knew what it did. Obviously, the plant personnel should have been better trained on this mission-critical system. And obviously, the plant never exercised its fuel system, or they might have figured out sooner, while they still had grid power, what this toggle switch did. But it was also a poor design by the fuel system supplier. A switch that critical should be labeled and it should be monitored. Going back to the Preferred schematic, anytime you take a pump out of automatic in a Preferred system, alarms start going off. Preferred puts another set of contacts on each HOA switch wired to an input module in the FSC controller, so we know the position of all the HOA switches at all times. These fueling systems are designed to run in automatic. If the system is not in automatic, it's not ready to do its job, and the plant personnel should be made aware. When the generator is shut down because it's sucking air out of the day tank, it's too late. The case study above was a fueling system failing its first requirement, providing fuel to the generators. The second type of failure of a fueling system is overfilling a tank. This happened at a facility in Dallas that prints credit card statements for the entire country. Supply pumps energized around midnight and started filling the day tank on generator number 3 from a 20,000 gallon main storage tank. The supply pumps filled the tank, kept going, pushed fuel up the vent, out onto the parking lot, and into an adjacent pond, and kept going. An employee taking a smoke break at 7 a.m. smelled diesel fuel and alerted facility personnel. By the time they shut down the pumps, about 3,000 gallons of diesel had entered the pond adjacent to the property. Cleanup costs for the pond exceeded $300,000. Someone from the New York City headquarters of this company recommended Preferred take a look at this fueling system and quote a replacement. I saw the existing system had all the right field devices, but the controls were done in a PLC by a company I had never heard of. I suspected the problem was with the controls programming. The company brought in a couple of sharp engineers who autopsied the existing system and came to the same conclusion. What they found is that a supply pump on float switch got stuck in the down position. This energized 2 supply pumps and energized a normally closed fill valve. As the oil level in the day tank increased, other float switches changed positions but were essentially ignored by the PLC controls. Two return pumps eventually came on, but one tripped on a thermal overload. So the two supply pumps were able to outrun the one return pump. Also, the interface from the fuel system to the building automation system failed to alert the plant that something was wrong due to programming errors. The fuel system controls were supplied by a local systems integrator, not a dedicated fuel system supplier. Each float switch had its own digital input, and the control system was never tested for this condition of conflicting inputs. There was no hardwired manual override to the PLC control system. I showed the facility engineers for this company the wiring schematic I presented on the earlier slides and demonstrated how a preferred fueling system would have hardwired de-energized the supply pumps in this situation, and Preferred received a contract to replace all the pump controls at this facility. The new Preferred fuel supply system was thoroughly tested, and the company hired a local consulting engineer as a commissioning agent to make sure the entire system was tested and ready to go. And then finally a programmer was brought in to fix the interface between the new controls and the building and automation system. Note, Preferred's fuel handling projects are full service. Each project is assigned an experienced engineer to review the contract plans and specs, call out the correct equipment for the project, and oversee the electrical schematics and programming of the system. Many fuel contractors buy parts out of a catalog and put the system together themselves in the field. When you specify different manufacturers for the pumps, and the day tanks, and the leak detection system, and the fuel polisher, you end up having a local contractor buy all these parts and try and make them work together. With a full-service Preferred project, all the components are either made by Preferred or selected by Preferred to work together. You get a control system that is programmed for that specific project. You get a job-specific sequence of operations and a job-specific wiring schematic. All the components are wired up in our shop and factory tested to make sure they work together. The two case studies above were about plants that just lost grid power due to an unforeseen shutdown by the utility. But in many parts of the world, we have to design generator fueling systems for much larger emergencies, a power loss due to a hurricane. We learned from Hurricane Katrina in 2006 that all components of the generator fueling system need to be above the expected high water mark. Now in New Orleans, generators, tanks, pumps, fill ports, and pump controls are either put on the second story or are built on steel platforms or stilts. After Katrina, the roads were not cleared in time, and most customers ran out of fuel in their main storage tanks because the fuel trucks couldn't get to them. Hurricane Rita hit the Texas coast east of Houston just a couple weeks after Hurricane Katrina. The difference was Texas was able to reopen the roads for essential traffic a couple days after the storm, so plants running on generators could get fuel deliveries. Preferred has an installation in Beaumont that ran on generator power for 14 days. They were so concerned about getting a delivery of bad fuel, their process was to completely polish the fuel in each tank after a delivery while they ran on their other tank. I was in Dallas, but I had my Suburban loaded with tools, parts, food, water, and camping supplies in case I needed to go down and work on fuel handling systems. Fortunately, Houston was not hit as hard as locations farther east. Power was quickly restored in Houston and restored in stages, so our local technicians were not overwhelmed. I conducted an entirely unscientific study talking to generator suppliers and fuel system suppliers after the two storms in 2006 to determine how well Preferred and other systems ran after the storms. I found bad fuel was the culprit in most of the cases where generators failed to start or to carry the load. The number 2 cause of failure was bad starting batteries, and number 3 was a problem with the engine cooling system. In case you missed it, Preferred's webinar last week was on fuel quality and how it is affected by tank design, fuel system design, and fuel polishing. You can see it at this URL, or if you just go to YouTube and search on these keywords, you'll find it. After Hurricane Katrina, we learned to move all the vital components of the fuel handling system above the expected flood line. New York City had similar issues during Hurricane Sandy. Most main tanks, generators, and fueling systems are in the building basements in New York City. So during Hurricane Sandy, most buildings lost grid power and generator power. All 4 Manhattan hospitals lost power and had to be evacuated. Bellevue Hospital had generators on the roof, but their main tanks and transfer pumps were in a flooded basement. They tried to keep the generators running with a bucket brigade, but eventually had to evacuate that hospital too. After Hurricane Sandy, the New York City Fire Marshal's office called Preferred and asked what could be done to prevent these fueling system failures in the future. The New Orleans approach wouldn't work because the pumps can't be moved too far above the main tanks due to suction lift limitations. So Preferred developed waterproof enclosures to go around our pumps. These enclosures have been tested to up to 80 feet of saltwater inundation and stayed dry and cool. I'm plagiarizing this part of the presentation from a presentation by Mario Franceschini, Preferred's representative in Puerto Rico. Mario and I did a presentation for Florida healthcare engineers in Orlando in October 2018 while a hurricane was bearing down on Florida. During Hurricane Maria, Puerto Rico experienced a total collapse in infrastructure similar to New Orleans after Hurricane Katrina. Power was out, water and sanitation facilities were mostly down, and essential workers were afraid to leave their homes because of looting. Hurricane Maria hit Puerto Rico on September 16, 2017. After 1 week, 100% of the island was still without grid power. After 4 weeks, 85% of people were without grid power. After 8 weeks, 57% were without grid power. And even after 4 months, 32% of Puerto Ricans were still without power. Mario found that many fueling systems didn't have an overall design for a certain amount of generator runtime. There was no unified design to the generator fueling system. He said fuel systems failed over time in ways that could have been prevented if long-term testing of the fuel system had been done prior to the storm. After Hurricane Maria, fuel became a precious commodity, and most facilities didn't have enough fuel storage. It took a long time to clear the roads so the fuel trucks could run again. Many systems were designed with single points of failure, so one pump or one valve could take down a generator. And again, like Texas, poor fuel quality was a common problem. Locations with higher humidity are going to condense more water in their tanks, and it's the water in the tanks that's the root cause of fuel problems. Mario also learned to have a store of cash at the house because credit and debit card machines were down after the storm. I love studying these case studies to determine what went wrong and how failures could have been prevented. We're going to be joined now by John Kadrich. John is based in California but travels the country starting up Preferred fuel handling systems. He has much more field experience with fueling systems than I have.
All right, everyone. Thank you for joining me today in this webinar. David and John are going to be getting on very soon. Before we begin and start the questions, I just wanted everyone to know that this presentation webinar will be on our website. If you go into webinars on our website, you can look at all the past webinars we've had, gather all that information you like. And if you would also like to view this one, it will be up there within the next couple of days. We're planning on doing a fuel oil startup webinar talking about the main startups or the main information and understandings that people need to know on how fuel oil system starts up. And that's going to be our next topic for, I believe that webinar is going to be in 2 weeks. And we're going to talk about some things that need to be understood about a system before, while you're designing it for the startup purposes. It looks like hopefully David and John can join me here. If you guys can hear me, just go ahead and unmute yourselves. Hopefully they will come on. Just give me a second.
This is Dave Oaf.
Hey David, how you doing?
Doing great.
This is John.
Hey John.
All right. So far we're doing a lot better than the Joe Biden live webinar. So John, thank you for joining us. John is a full-time service technician who you do about 90% of your projects are fuel handling. So you've got a ton more experience with this type of project than I have. John, what would you say is the biggest design mistake you see with mission critical fueling systems?
A lot of times the engineers don't ask us how these things actually go together and work. So I see a lot of weird piping issues that when I get out there, return lines aren't going where they're supposed to go. Leak detectors in places that you normally wouldn't put leak detectors. Out in California, things are a little different because it's always changing, and the fire marshals want new and updated stuff and don't bother telling anyone until it's the last minute and we have the system installed. So it's an ongoing issue.
Yeah, California is the only place I know where the fire marshal will expect things that they've never bothered to really write down and put into code. I've
Correct.
never seen that anywhere else. So how do you keep up with that? Just by doing a lot of projects and keeping in contact with the fire marshals?
Yeah, we try and talk to them whenever possible. Up till very recently, we were in good standing with the existing fire marshal, but she moved up and they brought in several new people, and they have pretty well taken everything we've done and changed it and made it way more difficult. So it's a as go basis to find out what they're changing, what they want, because it's definitely not written down anywhere.
Wow. So at the beginning of the presentation, I showed an energized to alarm circuit and had a list of things that can go wrong in an energized to alarm circuit, like a blown fuse, a broken wire, a terminal block not tightened down, a malicious rodent. I have personally seen all those things doing either boiler startups or fuel handling system startups. How about you? What's the weirdest failure you've seen in a fuel system?
People disabling the sensors. Uh, they think,
Disabling leak detectors?
yeah, oh yeah, I've seen it happen a lot. A fair amount of times, I should say. They don't understand that by doing that could cause the system to lock out. And when the alarm comes up, they just silence the alarm and go on their merry way. So our systems are pretty much set that if they're working the way they're supposed to, you leave them alone. You know, they work. There's not a whole lot of interaction people need to do, but they feel they need to do it anyway.
You know, I have a lot more experience, field experience with boiler systems than I do fuel handling systems, but I can think of several failures where when you go back and look through the history on the controller, you can see the operator pushing the reset button a dozen times before something really bad happens.
Yeah, or throwing a system in hand and walking away.
That caused a an overfill at a place in the Bay Area, right?
We had one. There's one down in LA. We're trying to figure out why it overfilled. Uh, Trying to get a hold of the customer because they called us, and I tried calling them back several times, and they've yet to return the call.
Okay.
So I'm headed down there next week to find out what happened.
So our audience for these webinars is mostly design consulting engineers. As a fuel system technician, what advice do you have for these engineers regarding fuel system design?
Call us from the very beginning. We've seen so many different things that could go wrong, and if we can get in on the beginning of these things, we can easily guide you away from the pitfalls that a lot of people have. We've been doing it long enough. We've seen pretty much everything you could possibly want.
Okay, and we have people spread out around the country. Most parts of the country just follow the NFPA codes that I listed for fuel handling systems. California has its own codes. Los Angeles has its own codes. San Francisco has its own codes, plus I guess what you call practices, because they don't write some of these things down that they want. and New York City has their own codes. John, can you think of any place else in the country where you need local knowledge to design a fuel system?
Most of the places we deal with, we try and get a hold of the local, like the fire departments or inspectors, to find out what their requirements are, because they're always changing. And that's one of the big things we tell people is, talk to these people to find out what they can do, because a lot of it's not in writing. You're looking at very old information.
So in California, you say the goalposts kind of keep moving. Is it for more safety, or which direction are they going?
It's more paranoia. A couple years ago, they had a system from one of our competitors overfill on a high rise. And within a couple months, all of a sudden we were told we had to have, all these high fuel warning lights on the fill panel and all the information going back to their BMS system. And every time we go there, they want to add another light, another alarm. So it's more paranoia than anything. It's driven.
So it's kind of like a belt and suspenders approach. They want multiple safeguards because
Right.
I guess an overfill in a high rise situation is much worse than what I see out here in Texas, where we store all our fuel outdoors for the most part. So if you overfill a tank, it's an outdoor situation, which is not nearly as bad as inside of a building.
Yeah, the last one that we saw that wasn't our system, the client said it was raining fuel in one of the rooms. So,
oh my God.
Yeah.
All right.
But that's why we like to get involved in these, so we know how the system's going to be put together. I mean, even if, again, I hate to say it, even if you don't buy it from us, give us a call so we can help make sure that it's up to the codes and specs that people want to see. It's way better for everyone.
Yeah, and we have you and Lee Carnahan in California. You guys are current with California, and we have John Haber in New York City. I would say New York City is the other place where the fuel oil codes are very special, and it almost takes a person full time to keep up with New York City, and that person is John Haber. Michael, do we have any questions on the chat?
David, I don't see any questions, but if anyone's not aware, you can push the question button. You can even submit some questions via the webinar software. We'd love to answer those questions. It looks like a little question mark with a comic speech sign around it, and then you can just ask us questions in there if you do have any questions. I don't really see any currently, David.
Okay. John, I did a startup here in Texas on a multi-node FSC based fuel system, and I had the program on an SD card, and I instructed the plant guy to tape the SD card to the inside of the cabinet so that he'd have it right there if he ever needed to reload the program. And he took me into his office and he showed me a small stack of laptops that he kept with out of date operating systems, because he had equipment all around the plant, and some of it, could only be reloaded with Windows 8. Some can only be reloaded with Windows 95, and this was just a couple of years ago. All right, I've taken the collar off of the dog. Thank you.
Yeah, I've seen that as well. The nice thing about our FSCs is if we send you a memory stick, you can just pop it in the unit and it'll pull it right out, update it, and you're done. If you have to update the display, all our software is backwards compatible, so it's fairly easy.
Have you ever had a dead FSC on a project?
No, that's one of the things that I think the worst I've seen is when the electrician wired it up, he shorted one of our inputs. And then we sent one over to Dubai for a military base, and when it got there, it had a little extra rattling inside. And I guess the trip and the abuse broke one of the boards inside. But that's about the worst I've seen. I mean, they're very reliable.
Yeah, I was going to say they've made it really easy to replace an FSC hardware node and made it really easy to upload a new program, but I haven't had to do it yet.
Right.
And I checked with our factory, and the warranty rate is actually less than 1% on these controllers. And I
Yeah, that
suspect
doesn't
most of that
surprise me.
1% is things that are dead on arrival, like the one in Dubai,
Yeah.
shipping
Yeah.
damage.
Hey,
So,
real quick, guys, we do have some questions here. Let me just get through these or ask a couple. So we have one. It says if we have to have the fuel tank in the basement, can they be waterproofed? So I guess she's asking if the fuel tank is in the basement.
Most of the fuel tanks are waterproof, except for the vents.
yeah, so I guess that just becomes a matter of where you locate the vent.
Yeah.
And that's something I always urge people to call their local fire marshal, because it seems like tank venting restrictions vary all over the place.
Yeah, definitely. I know in San Francisco, at one point they wanted to have a separate emergency vent and working vent for the tank and the rupture area. And then you could join some of them up depending if you did the right calcs. And now I think they went back to separate. So
Yeah, so to directly answer that question, the tanks are waterproof, but they have to be vented to atmosphere, so you need to pay particular attention to where you're venting that. And there are restrictions within, I think it's NFPA 30, as to how high you can run that vent, and those restrictions are different in New York City. And then the other concern is tanks are much lighter than water. Because diesel fuel is lighter than water and the tank isn't completely full, it's much lighter than water. So if you have a tank in a basement and the basement floods, that tank is going to want to buoy up. And I heard stories about tanks in lower Manhattan during Hurricane Sandy that lifted up and were bobbing around in the water in the basement and knocking
yep.
all the things off of the tank.
Well, if it's located in a basement, it should be anchored, per the specs of the tank. If they're using like a convol tank, those things are solid cement outer shells on those. They're pretty heavy. But if you're running into a water issue, you also have to think about how you're transferring the fuel. Your pumps now need to be protected. So we've got a line of pumps specifically for that.
Yeah, and we developed those waterproof pumps after Hurricane Sandy, but so far we've sold them in New York City, we've sold them in Boston, and we've finally, after all these years, just provided a few to Florida. But it seems like they've been kind of slow to catch on in areas that haven't been hit with a hurricane lately.
Yeah. And you also have to consider, if you're in a situation where there's going to be water, your leak detectors need to know the difference between fuel and water. So you have to have smart leak detectors.
Discriminating leak detectors.
Yep.
Yeah, because a float's going to react to water the same way it would react to oil.
Right.
Okay,
Great.
Michael, you
Yeah.
have more questions?
Yeah, we have three more. So it says the double NC valve at the day tank fill line should be controlled from the FSC or day tank control panel. So I'll read that again. The double NC valve at the day tank fill line should be controlled from the FSC or day tank control panel.
Usually the day tank control panel would control that. With ours, it's one control panel for the most part that does everything. So it makes life a whole lot easier. You've got one control panel for the main tank, and then you've got a control panel for the day tank. So.
And John, we've got two different ways of, or two different sequences for those fill valves. We'll always have one valve that's energized by the day tank control panel, but sometimes we'll put a second valve in there that's run directly off the leak detector for the day tank rupture basin, right?
Yep. Yeah, it's hard coded. Yeah.
Okay, and that valve is usually a normally open valve that runs directly off of the leak detector float?
Yeah, normally open.
Okay. So We've got a couple of ways of doing that. We can either have two normally closed valves, both actuated by the FSC controller, or we can have one normally closed valve that gets energized by the controller, and a normally open valve that's held open by the leak detector. And if we detect a leak in that day tank, then we close that valve.
Right.
Great. Next question. Are you guys?
Yeah.
Okay,
that's
great.
everything I know on that subject. So.
Yep.
Do all sensors and controls on a fuel oil system send operational data to the computer interface system for annunciation of conditions, alarms, etc. data, or engineering data, calibration status, etc.? Let me read it again. Do all sensors and controls on a fuel oil system send operational data to the computer interface system for annunciation of conditions, such as alarms, engineering data, calibration status?
On our systems, if a sensor is hooked up to it, it gets put into the BMS. So if you have a fire panel or management system, we can send the status of all the systems attached to our device. But you also have to think about on USTs, those are usually monitored like a Veeder-Root or Franklin or some other monitoring system. We do talk to those, we get information from it, but we usually don't pass that information on because it's coming from another device, another controller.
So when you do a project with Preferred, you're going to get a Modbus address list. It's in the O&M manual, and that'll include a Modbus address register for everything we've mapped out to the controller, and the customer's building automation system can pull any of those addresses they want. And typically we make more information available than what most customers want. They usually want to know when pumps are running, and they want to know when there's an alarm, maybe there's a leak. And I mean, I've seen us provide 30 or 40 points, virtually everything the controller knows.
Yeah.
Yeah, we can also give you gallons. If we're monitoring the gallons through a continuous level probe, we can give you the gallons. All the systems are custom, so whatever you want, we can pretty much do for you.
Excellent. Next question is, any issue using paddle type flow switch?
Only if you put in flow restrictors that restrict it below what the paddle sensitivity is. Otherwise, they work great. Way easier to deal with than the electronic heat sensing probes we've used in the past. For me, I'd rather have a paddle switch. That way you know they're on, they're off. There's no guessing about it.
So, John, whenever we do a transfer pump set, we ship a paddle type switch loose.
Correct.
For the contractor to install. Are there any do's and don'ts about where to put that flow switch?
You always want to put it on a horizontal run. I have seen people try and do it vertically, and it's not accurate. The paddle will open and close without the fuel going through the way you want. If you plan on doing under 3 gallons a minute, you have to go with the electronic high-tech flow switches, because our paddle switches don't go below, I think it's 5 gallons a minute.
John, how often do you see flow switches at the day tank fill manifolds?
Probably about a quarter of the time.
Okay.
The thing about those flow switches is you don't want to have them outside where it's going to get rained on, because if water gets in the top of those flow switches, the electronics in there, the reed switch will fail.
Oh, I got
So
you. Okay.
Yeah, if you can keep them inside where they're protected in an enclosure or something, they work way better.
I always try to specify them, because I think I think it's great to know that if we're trying to top off a day tank and we energize a supply pump and we open a fill valve, if oil isn't flowing to that day tank, that could be caused by a bunch of different things, and none of them are good. It could be that
Correct.
one of those hand valves is closed and that day tank is not going to get topped off, or it could be that the oil is going somewhere else, like you have a leak, a spill, or a union not tightened up. Is it true if you completely run a diesel engine out of oil, can they reprime themselves, or do you need to get a technician out to reprime the engine?
Normally, if you know what they're doing, how they do it, you can reprime it. But if it runs out of fuel, there's other things to worry about, like it starts running lean and you've just started damaging the inside of the fuel injectors and stuff. Yeah, they don't like running out of fuel. But
Okay.
usually when we sell a system, we have a flow switch coming out of the pump set. That way we use that as a pump fail rollover. We know if a pump has failed, it'll roll over because of that switch.
All right. And there's typically a float switch in the day tank or the belly tank below our pump on switch that turns off the engine, correct?
In California, they don't do that very much. As far as our system goes, as far as the generator goes, no, I've seen them run out of fuel. They'll go low fuel, and then next thing you know, they've run out. So I would never rely on the generator's low fuel warning at all.
Okay.
Hey, David. So it looks like we do have one other question. It says NFPA 37 has some statements that prohibit valves or traps in overflow piping. In cases where there is not a dedicated overflow line, is it typical that the statement would apply to fuel return piping?
On fuel return piping, you're not allowed usually to have solenoids or motorized ball valves or anything that will impede the flow. You can have a check valve, which is always a good idea, because if you have multiple tanks returning fuel, the check valve will keep it from backing up into another tank. But usually solenoids are a bad idea.
But if we have multiple main storage tanks and we want to, we want the ability for all generators to be able to run from any tank, then we have tank selector valves.
We usually have tank selector valves for the supply, but if you put in a OPV on each of the tanks for the returns, it'll fill up that tank until it hits the OPV, and then it'll just roll over to the next tank. So it's a mechanical stop inside the tank.
Okay, I got you. The overfill valve.
Yep.
Okay. We're getting good questions today.
Yeah, great questions. Yeah, great question. If anyone else has any more, we'll be more than willing to answer them. So we will just hang on just for a few minutes while maybe someone's asking one, but great answers as well. Appreciate that. Let me just see if we have any more.
So John, I was called out to a site that, and we shouldn't name names, but you've been there too. They started to overfill a tank, and luckily this was a 24-hour staffed location. So the guy on duty heard oil hitting the ground and isolated this main tank right away. And I went down to autopsy the system because they were stumped. They didn't understand what had caused this. And after talking to the operator, I found out that they had a return header that returned oil to all of their tanks. They had a bunch of tanks, and the valves were leaking by because the flow was very low, so the check valves weren't closing, and the solenoids that were used weren't positive shutoff.
Oh.
Unfortunately, they only dropped less than a gallon of fuel because somebody was paying attention. It ended up being just a diaper spill. But have you seen an issue like that before, where headered piping can cause a tank to overfill when you wouldn't think that it would be possible?
Yeah, and usually it's because they did put in a series of solenoids, and after time, the guts of those solenoids being submerged in diesel tend to fail. I've got a site here that is not Microsoft, but it's their competitor, where I was returning fuel to one of three tanks, and I noticed that two of the other tanks were slowly rising as well. And if you put your ear up to the solenoid, you can hear it drain through. Now, this system was built probably 15 years ago, so we would do things a little differently these days.
You know, a lot of solenoids are not designed to be tight shutoff. So over time, with pressure on the solenoid, it will slowly leak by.
Yeah,
And
I for
then,
one, like motorized ball valves.
yeah, they're more expensive, but man, I think they're worth it.
Yep.
Uh, the other thing, I had a slide on there where I showed how we put 4 switches in a tank, and the 80% switch is the pump off, and the 90% switch is the turn on the return pumps and hardwire lockout the supply pumps. That 90% switch sits in the air most of the time because the oil level doesn't typically go over the 80% pump off level. And when I'm commissioning a system or checking a system, I find that that 90% switch that sits in the air most of the time is the most likely to stick.
Yep.
Have you found
Yes, it gets
found the same?
gooey. Yeah, it gets gooey on the bottom of the float and sticks to the C clip.
Yeah, so when I instruct people on how to exercise their fuel system, occasionally I tell them to carefully watch and fill the tank up to the 90% level and make sure that that switch works too, because it's a very important switch. It hardwire cuts off your supply pumps and it energizes the return pumps, but it's the most likely to fail because it's not constantly getting cleaned and lubricated by sitting in oil.
Right.
It's sitting in air. And with
Well,
ultra low sulfur diesel, there's a lot more junk in the ullage space of your tanks these days.
yeah, you get a lot of condensation.
I've had people in South Texas tell me that they've inspected tanks and found barnacle-looking things growing on the
Yep.
upper inside of the tanks.
Yeah, we get those in San Francisco. Yeah,
Is it a barnacle or some type of? Is it a
it's
shellfish type of thing?
it's a little microbial creature that's like a piece of sand, and they just grow and grow and grow. A lot of gas stations in San Francisco have that problem. They have to clean the filters, the strainers a lot, and I've actually seen strainers implode because the pump was working so hard sucking in that stuff. So
So if
yeah,
those things grow on the shaft of a float switch, they're gonna keep the float from working
right.
because it
Yep.
doesn't. Those floats don't have very much force on them, you know.
Yeah. One of the things when people design these, I suggest is on the control probes, put them on a union. That way they can be easily removed and tested. Because when we go
Yeah.
through and do our annual testing, if they're not, we have to unwire everything, and that doubles the time it takes to test it. Whereas if I
Yeah.
just got to bust a union, you can inspect it, you can see what's going on, you can make sure it works the way it's supposed to.
Yeah.
It makes life a whole lot easier.
Put it on a union and use enough flex conduit so that you can
Yep.
pull it out far enough to get to those floats for sure.
Right. But you got to remember to add the extra length that the union gives you so it doesn't raise your floats. So when you design it, you have to add that length to the original design.
You know, I must be really bad at using a tape measure because I've had a couple of jobs where I've ordered PLS type switches and then had to talk Dennis into sending me new ones that are an inch and a half longer or something because I forget to take off
Yeah,
something.
right.
Great.
That's what we have Marlon for. We run that past him. Marlon is our local engineer in California. So whenever we have issues, we can run it past him, and he usually catches the stuff that we didn't see.
It's the same thing with me and DIY projects at home. I have to measure like 3 or 4 times to make sure I get something right. Michael, anything else?
No other questions. Well, we did have one other question. It says, will the slides be available to us? And yes, they will be. The whole video will be up on our website under the whole under our webinars tab. So you can just go there and you can watch it freely, look at the slides, look at more in-depth information about the slides. One thing I did get some information from Alex Kenny, which chimed in. He did say we were referring to that high level switch. He said a return pump helps with that dry high level switch, since it can be tested completely by filling it above the return and then using the return pump to bring all that fuel back down. So basically you can actually test that if you have a return pump on your day tank. But I know in some places that's not supposed to be.
Well, with the PLS4, you've got the low, the pump on, the pump off, and the high. And sometimes people put in a backup high. And when we see sites like that, we just we open the bypass on the supply and just fill the tank as far as it'll go and wait for the return pump to kick in. And if you designed it right, the return pump should be able to pump out the tank faster than you can put fuel in it. So then you know that your system's working and the chance of a spill is lowered.
Yeah.
John, it makes me very nervous when I manually fill a tank above that 80% pump off, and I'll toggle the pump on for a couple of minutes, turn it off, watch the level. Am I the only one?
Nope. I usually open up another port, get there with my flashlight, and on the bypass, when I start seeing things get a little higher, I'll close the ball valve down so it doesn't creep up as fast. Plus, I've got a tape measure stuck in the tank so I can see exactly where it is, because looking at diesel fuel with a flashlight through a small hole, it's not the easiest thing to do to see where it is.
So I was doing a recommissioning on a day tank a few years ago, and this is probably literally the dumbest thing I've ever done on a fuel handling system job. I was testing that 90% switch, and it had already stuck on me once. So I was testing it. Once it sticks, I want to make sure it works again like 5 times in a row before I leave it. And on this job, we had a head level transmitter as well in the day tank to tell me the level. And I had written down where that 90% switch, how many gallons I was supposed to make. And I went a little bit past there, and the switch didn't change position. And I went a little bit past, and I slowly filled it up some more. And then the level went from like 180 gallons to 400 gallons. Just boom! What is going on? So I opened up the emergency vent to look inside the tank. Got oil all over myself because
Oops.
you knew I was starting to push oil up the vent, and
Yep.
that DP switch, that should have been the clue that I was pushing oil up the vent, because my pressure went super high in the tank, and that gets reported as really high oil level. So I came home smelling like diesel again.
Yep. One thing we do to make sure that doesn't happen is we put vent leak detectors in there. So if fuel does go up the vents, it sounds another alarm. And that's part of the permissive chain, that if fuel gets up to that sensor, it literally locks the whole system down. That's it. It'll turn the return pump on and just let it run until it hits low fuel.
Those are nice, especially in belly tanks or base tanks that aren't very tall.
Yeah.
I did a job in Texas where we had a base tank underneath the generator that was 5 inches tall, and we had to fit 4 switches in it, and we just couldn't. I put a PLS1, a PLS2, and then a vent switch in it.
Yeah.
That was the only place to put that overfill switch.
Yeah,
So,
even with an ultrasonic, you're kind of tight on that because of the dead bands of the ultrasonic. 5 inches of tank is a total pain in the butt.
All right. So we are at exactly an hour now. I want to thank everybody for sticking through to the end. I hope you guys found this to be instructive, and If you have more questions, you're welcome to email me or email John. Both of our email addresses are on the screen now. If it's a field issue, you're probably going to get a better answer out of John than I do, because he probably does 10 times as many of these systems as I do.
I do see a fair amount.
Real quick before we leave, just one last question. It says, please clarify what fuel system components that are recommended to be above flood level and what components for fuel oil tanks filling will be at street level. Just kind of comment that real quick before you head out.
If I could have my way, I would take the New Orleans approach and put everything above the expected flood level. But in some places, it's just not possible. So, the main tanks can be made resistant to water, and we've made the supply pumps resistant to water. I would put everything else up above.
Yeah.
Okay. Simple enough. All right. Like David said, thank you everyone for sticking around and coming. Like I said before, if anyone would like a copy of this presentation, it will be on our website within the next 1 or 2 days. And you can be able to watch that freely as many times as you want. You could also binge all of our other webinars if you are feeling bored and need something to watch. They're also there. Okay, thank you, David. Thank you, John.
Thanks,
Thank
guys.
you.